This talk is called Blackhole Information Paradox. So they have trouble combining general relativity and quantum mechanics, and that leads to the black hole information paradox. And I'll be dealing with this article called Escape from a Black Hole. So picking up the article from where it says the enigma is the paradox of what happens to information in a black hole. By investigating this question, physicists have discovered that the mere existence of black holes is inconsistent with the quantum mechanical laws that so far describe everything else in our universe. Resolving this inconsistency may require a conceptual revolution as profound as the overthrow of classical physics by quantum mechanics. Now, black holes are an idea that really comes from general relativity, and it's saying it's inconsistent with quantum mechanics. And when it says may require conceptual revolution, means something is wrong with the understanding of general relativity, or with the understanding of quantum mechanics, or the understanding with both of them. So skipping on a bit to where the information problem is, the problem arises from one of the simplest questions we can ask about black holes. What happens to stuff that falls into them? We need a little refinement here to fully explain. First, according to our present quantum mechanical laws, matter and energy can shift between different forms. Particles can, for example, change into different kinds of particles. But one thing that is sacred and never destroyed is quantum information. If we know the complete quantum description of a system, we should always be able to exactly determine its earlier or later quantum description with no loss of information. So a more precise question is, what happens to quantum information that falls into a black hole? Our understanding of black holes comes from Einstein's general theory of relativity, which describes gravity as arising from the curvature of space and time. A common visualization of this idea is a heavy ball deforming the surface of a trampoline. This warping of space-time causes the trajectories of massive bodies and light to bend, and we call that gravity. If mass is sufficiently concentrated in a small enough vicinity, the nearby space-time deformation is so strong that light itself cannot escape a region inside what we call the event horizon, and then we have a black hole. And if nothing can travel faster than light, that's the light speed c in the vacuum, included information, everything must get stuck inside this boundary. Black holes become cosmic sinkholes, trapping information along with light and matter. So this belief that nothing can travel faster than light, meaning light speed in vacuum c, is what's messing things up, and it's a false belief based on misunderstanding relativity, as I pointed out in previous videos. Anyway, let's get along with mainstream physics beliefs about there being no faster than light speed in vacuum c. Things just get weirder. The article carries on, but the story becomes stranger, i.e. weirder. What may be Hawking's greatest discovery is his 1974 prediction that black holes evaporate. The finding also led to the startling idea that black holes destroy quantum information. According to quantum mechanics, pairs of virtual particles pop into existence all the time, everywhere. Typically, such a pair consisting of a particle and its antimatter counterpart quickly annihilates, but if it forms near the horizon of a black hole, one particle might pop up inside this boundary and the other outside. The outside particle can escape, carrying away energy. The law of energy conservation tells us that the black hole has thus lost energy, so the emission of such particles causing the black hole to shrink over time until it completely disappears. Well, that's arguable, but that's what they believe. So, continuing on with what it says, problem is that the escaping particle, known as Hawking radiation, carry essentially no information about what went into the black hole. Therefore, Hawking's calculation appears to show that quantum information that falls into a black hole is ultimately destroyed, contradicting quantum mechanics. This revelation initiated a deep crisis in physics. Great advances have followed from previous such crises. For instance, at the beginning of the 20th century, classical physics seemed to predict the inevitable instability of atoms, in obvious contradiction to the existence of stable matter. And this idea that classical physics seems to predict the inevitable instability of atoms is just based on ignoring Boscovich's theory that extended Newtonian physics to deal better with attractive and repulsive forces acting at a distance. So basically it's the physics people ignoring the history of their subject. They suddenly decide we ignore what's been going on before in the 18th century when they tried extending Newtonian physics, and then they make false statements about what that Newtonian physics is when they're calling it classical physics. So this is the person, Roger Boscovich, and I'll let you read that for a moment if you like. It says about him giving the first coherent description of atomic theory, and they just sort of like ignore that when they teach in physics. So this is what the atom is dealt with. You've got particles around the nucleus and they're obeying Boscovich's curve for forces, and so the forces can balance out when there's an attractive and repulsive force acting between the nucleus and the particles around it. You can get balance, and it all gets ignored and forgotten when the physics establishment makes statements like this. And the statement in the article saying, for instance, at the beginning of the 20th century, classical physics seemed to predict the inevitable instability of atoms, in obvious contradiction to the existence of stable matter. So they're just ignoring the work on classical physics after Newton, which led to what Boscovich was talking about. They just falsely represent classical physics. Anyway, skipping over the false representation of what is called the quantum revolution of physics, article says, this radical idea helped to establish the basis of quantum mechanics, which fundamentally rewrote the laws of nature. Increasingly it seemed that the black hole crisis will similarly lead to another paradigm shift in physics. So we have this black hole crisis and it needs another revolution in physics. If the quantum revolution and the relativity revolution had not been messed up, i.e. with not properly taking into account Boskowitz, then they probably wouldn't have needed this extra revolution. Anyway, dealing with the problem they have got is the information problem. Black holes were predicted by general relativity, and mounting astrophysical evidence supports their existence. And I'll lead you to read the rest of it. So, and the possible solutions they offer are these diagrams. You've got the classical black hole and with its event horizon, and the problem they point out with that is it contradicts quantum mechanics and energy conservation, which say the information cannot be destroyed. And the next proposal is soft hair. And what it says about that is most experts do not regard this picture as providing a convincing resolution, and there are more attempts at solution. These are the other attempts. You've got the fuzzball, the firewall, and the quantum halo as attempts to fix this problem with the black hole information paradox. Basically, the solution being offered is a need to alter their beliefs, which they have at the moment about the constant light speed in vacuum of being C. So, ending it here, the article carries on for a few more pages, but basically going over its confusions, which is already just generated. These confusions created by relativity, where they have to modify their understanding of relativity in some way to sort out this information paradox in the black holes. And that's the end conclusion. Thank you.